Hello everyone. Let's discuss topic about algorithm, decision making, uncertainty games. Let's start. There is introduction is Expectimax algorithm is a core concept of artificial intelligence and game theory designed to enable AI agent to make optimal decisions. In game where the outcome are not fully predictable, unlike the minimax algorithm, which is used for deterministic two players games like a chess game. Expect is especially tolerated for games that include element of chance, such as a dice roll, random card drawn. The fundamental ideas behind expecting math is to calculate the expected utility of each possible move rather than simply assuming the worst case scenario. There is landscape of decision making under uncertainty. There are two types. The fundamental challenges of uncertainty in artificial intelligence. There is include decision making complexity. In decision making complexity, AI systems face difficulty where outcome of action are not deterministic. Second is a real world unpredictable environment are and suddenly ultrasound influenced by chance factor, incomplete or missing information, rather agent behavior. Third is need for probabilistic reasoning, and fourth is beyond worst case scenario. Second is an overview of games theory and advanced search AI. There include is the evolution of game playing algorithm forms deterministic to stochastic diagrams. Early games playing algorithm like Minimax were developed for deterministic perfect information games where outcome depends solely on players' action like a checkers. These algorithms rational optimal and no element of chance or randomness. In real world games and many practical decision problem often involves stochastic elements such as a dice roll, card drawn, or uncertainty environment factor. To handle randomness, searching introduces chance nodes into decision trees, generalization minimax into algorithm like Expectimax. Expectimax incorporate probabilistic reasoning by calculating expected utilities over possible chance outcomes. There is foundation of minimax algorithm for deterministic game. There are three types. First is minimaxing the minimum gain. In minimaxing minimum gain, AI assume the component always play optimal to reduce AI player. Now there is AI choose the move that guarantee the maximum of it minimum possible gain. Second is a adversarial search technique. It is used in a mainly deterministic, perfect information, zero sum game like a chess game, tic tac toe games. And third is recursively game tree exploration. The algorithm explores the game tree recursively under simulation term for both players. There is a two nodes. First is a max node and second is a mean node. In max node, AI turns maximum score and in mean node minimizing AI score. Which moves should the AI player choose? There are three nodes, max node. In max node, represent the AI optimal move to maximum utility. Mean node represent the optimal moves to minimize AI utility, and chance node. It is last node represent random event or probabilistic outcome. There are many limitations. Minimax in probabilistic environment. First is the minima algorithm is used for decision making in deterministic two-player zero sum game like a chess game, tic tac toe games. Second is it assumes both players act rationally and aim to maximize their own gain while minimizing their component gain. Third is a minimax select. The move that guarantees the best worst case outcome of optimal strategy against an optimal component. Alpha beta pruning is an optimization technique that reduces the number of nodes evaluated without affecting the final decision. Max node Mean node, minimizing the foundation of for many AI games, playing system in deterministic setting. It requires perfect information and assumed to randomness. There is a limitation of minimax in probability environment. The minimax algorithm challenges. There are very challenges. First is a high computational AI cost. They require significant processing power and time. Second is exponential growth in game tree leads to unmanageable decision path. Third is unpractically for complex game. There is not suitable for games with many possibilities. And last, limited to perfect information scenario. There is only work when all game information is no. There is a very advantage. Disadvantage is present. Advantage is uh, optimal play. In optimal play, guarantee optimal moves. Minimax assume that both players will play optimally. Uh, this means it can compute the best possible move for the players given the state of the games. Second is a game theory foundation. In game theory foundation, theoretically soundless. The Minimax algorithm is based on sound game theory principle. The work is well any two players zero sum game where one player is gain and other is loss. Disadvantage is exponential growth. In exponential growth, the main drawback is the explosive number of possible game state. For complex games like a chess or search, a trick become too so large that it can be impractically to explore every possibilities. Second is a search term. Deep search. In deep search, to evaluate good moves, algorithm might need to search in a very deep level, which make a lot of computational power and time. Third is memory requirement. The high memory consumption, sorting the entire game tree or even partial game tree can require large compound of memory, especially for deep games. This is the advantage and disadvantage. The second is a max node player's optimal choice and mid components optimal play inapplicable. In max node, the max node which signifies the AI players turn the overreaching objective is to identify and select the move that is will maximize the expected utility of the subsequent state. And there is a included AI systematically evaluate all available moves from the current state and then commute to each action that is projected to lead to the highest expected value in long run. The in mean load, optimal current counterplay. In optimal counterplay, minimax principle, the component is assumed to act optimally against the AI. And if the component choose the action, the minimize the AI utility. Second is a lower utility for A. In lower utility, the algorithm assumes the component select the move leading to the lowest possible playout for the A. This model is the worst case scenario from the AI perspective. There is a very calculate code in utility value. This is a code for calculation and propagation expected utility. Second is a step-by-step example of dice game scenario. There is a move A, move B, and move 3. This explaining which move is maximum expected utility. Move A, which is a projected to lead to the highest expected value in the long run. Move B may offer immediate gain but lower long-term utility, and move C could result to moderate utility with balanced risk. There is a this is three moves A, B, C, and these moves is a maximum expected utility. The Expectimax in action, application in games and real world scenario. Decision making in psychometric games. The which algorithm is used for decision making in psychometric games. There is two types, Expectimax and reinforced learning. In Expectimax, suitable when the complete model for the environment is available, allowing the systematically maximization of expected utility. And second is the reinforcement learning. There is a model when the environment model is unknown or complex, enabling learning through experience. There are 48 optimizing more in random title generation environment. Second is the pokers and other card games with incomplete information. Moderating unpredictable or some optimal component in Pokemon Ghost. This is a game, and in many real world scenario or games, Pokemon component or unpredictable or optimal, not always acting to the minimize your utility perfectly. Board real word application, the robotics and automation system in uncertain environment, the financial decision making and market stimulation. Last is the strategic planning under probabilistic outcome. This is a information about the Expectimax algorithm. Third, computational complexity and inherent limitation of Expectimax. There is a time and place complexity analysis. In time and in place complexity analysis, computational complexity of the Expectimax algorithm is primarily governed by two critical factors. Branching factor of the game tree, which is represent number of possible moves or outcome. A second factor is maximum search depth, which is detect how many layer of the future the algorithm explore. This is a table for comparative computational complexity of minimax and expectimization. There is include features, time complexity, place complexity, pruning capability, sensitively to utility magnitude, component model, applicability. The problem of exponential tree both in deep search space. There is a indicate by an Ohm's law because complexity expect to match in susceptibility to exponential tree growth. Second is sensitivity to the accuracy of probabilistic model. Then the Expectimax are non optimally and risk taking behavior. The fundamental difficulty of cloning is matched tree. There is it included. Optimize experimentation search and optimization Expectimax search. There are two search, depth limited search and heuristic evaluation. In depth limited search, turn rating search at a predicted defined depth, and heuristic evaluation search estimate non-terminal state value. How many manage the complexity of optimized trees? There are varied trees. The manage is important to how. First is a Monte Carlo sampling. It reduces complexity by sampling outcome. Second is limit look ahead. Restricted search depth to manage complexity. Third is approximate evaluation. In approximate evaluation, simplifies calculation for faster result. And approximate pruning offer efficiency but may sacrifice accuracy. Advantage technique and optimization for Expectimax search. There are two types. Principle of heuristic design of Expectimax. The first, there are include accuracy, computational lightweightness, reflection or game objective, sensitive to magnitude. And second is a depth limited search and heuristic search function. There are two, depth limited search and heuristic evaluation function. In depth limited search address, the search is turnically limited at the predefined maximum depth denoted as D. This effective transformation and infinitely deep or expensively deep game tree into finite one. It allows the algorithm to produce decision within a reasonable time constraint. Second is a heuristic evaluation function. In heuristic evaluation function, defined the cutoff depth instead of revealing the actual terminal utility. Heuristic evaluation function, often denoted as a utility state. A case study. In case study, heuristic for the 2014 games in weight matrix, empty tiles, mono, tonicity, smoothness. In weight matrix, this is a heuristic assign higher utility to get configuration where higher value tiles are possible positioned in specific strategical advantage areas such as corners along the edges or border. Second is empty tiles. In empty tiles, heuristic rewards state that possess greater number of empty cells on border. Third is monotonicity and smoothness. In monotonicity, heuristic adds utility to grid where tiles are arranged in consistently decreasing or increasing order along rows and columns. It decrease and increase order along rows and columns. Smoothness. In smoothness, heuristic rewards state where tiles similar value are choose proximity to one another. How to design effective heuristic for Expectimax. There is a four method of reflection or game objective. In reflection and game objective, capture and quantifies feature correlated winning condition. Second is sensitivity to magnitude, generate meaningful numerical values for expected value calculation. Third is computational lightweightness. It allows rapid evaluation of state, avoiding negation of depth limited search benefit. And last is accuracy. It is a reliable approximation of expected utility, minimize diverging for actual value. The summary table key heuristic expecting math in 2048. There is a heuristic weight matrix empty tiles more smoothness in principle benefits is there. It is a summary of this expecting math heuristic in 2048. The specialized pruning technique, the minimax approach. There are four specialization. First is the specialized pruning technique, the minimax approach. Second is the minimum technique developed by Burnham Ballant. And third is the parallelization strategy for expecting max. And fourth is the enhancing aspect efficiency, transposition stable, and state caching. This is a four specialized pruning technique in minimax approach. Implement mode calorie research. In mode calorie research, there are simulation, expansion, selection, back propagation. It's involved in simulation. Perform randomized simulation to reach terminal state. Expansion, add new child nodes to represent potential future state. And selection, balance exploration and exploring using UCB1 criteria. And by propagation, update nodes value based on simulation outcome. The strategy, the strength and weakness of MCTS versus Expectimax. This is strategy of MCTS and MTCS weakness. Strategy is scalability, no expected probabilistic model needed. Any time algorithm handle incomplete information, and weakness is convergence, evolution quality, less optimal in shadow depth. The Expectimax strength and Expectimax weakness is optimal for strength is optimal for given depth model and directed the expected value calculation. Weakness is a computational cost require expected probabilistic is The algorithm to use for game strategy. The MCTS is a use in game strategy for suitable complex games with a high branching factor and incomplete information but required many stimulation. And Expectimax is a used for game strategy for optimal for games with non-probabilistic and shallow depth but computational expensive. There is a reinforcement learning and micro decision processing. Mm, and there are reinforced learning and micro decision processing. But they include expecting trees as a represent MDPS means micro decision processing and strategic consideration when to choose RL over extreme is a model availability, computational scale, adaptability, optimal versus practically. Last is the balancing stability and adaptability in AI decision making. There are two types of experiment and reinforcement learning. In experiment limited scalability, fixed model availability, optimal expected place, and reinforced learning are suppressive scalability, continuous adaptability, particle policy recovery. This is all about decision experiment algorithm and decision making. Decision very few points is important. I so hope this is a thing understand you and thank you.